This is Brilliant Moon, and today we're going to be learning about the layers of the blockchain. Blockchain technology offers benefits like transparency and unbreachable security by enhancing efficiency, minimizing costs, and eliminating intermediaries. When it comes to Web 3.0 and Decentralized Ledger Technology or DLT, especially in connection with blockchain, you may have heard people talk about the different layers of blockchain. What exactly are they, and why are they so vital? There are 6 layers in the blockchain: data layer, network layer, consensus layer, activating layer, contract layer, and the application layer. The blockchain uses OSI, Open Systems Interconnection, which is a reference model for how applications communicate over a network. OSI separates the 6 levels into 3 layers from bottom to top: layer 0, layer 1, layer 2, and layer 3. Layer 0 blockchains are like the internet backbone. This layer consists of the hardware required to run the network and the consensus mechanisms without any glitch. Layer 0 blockchains are fundamental building blocks that allow Layer 1 blockchain to communicate with each other, a process called cross-chain operability. The Layer 0 of the OSI model is responsible for integrating blockchain technology with existing networks. It's a foundation layer that makes transactions come to life. Some popular Layer 0 examples are Cosmos and Polkadot. Cosmos is the foundation for Binance Chain. The core structure of the blockchain is not changed by Layer 0 scaling methods. This allows developers to maintain the ecosystem's core concepts while also improving performance. Layer 1 blockchains are also called as public chains. It governs the protocols that ensure security across blockchain networks. Layer 1 encompasses the consensus mechanism, coding language, and all the rules embedded in the code for the operations of the blockchain. Therefore, sometimes this is also called the implementation layer. When users mention the Bitcoin blockchain, they are referring to this layer. Some famous Layer 1 chains are Bitcoin, Ethereum, Solana, Cardano, and Avalanche. What's special about Layer 1 blockchains is that they are independent blockchains that can work without any other chains. They have their own structure and mechanisms, their own consensus, ledger, nodes, and tokens. Let's move on to Layer 2. Layer 2 refers to the blockchain's contract and application layers. Layer 2 blockchains are built on top of Layer 1 chains. Layer 2 is a network built on top of the blockchain to provide better scalability, availability, and privacy for people using blockchain technology. Layer 2 blockchains are designed to address the scalability issues of Layer 1 blockchains such as Ethereum. Now we'll also learn about something called classic blockchain trilemma. To improve blockchains, processing power must be added, but doing so means the addition of more nodes, and this clogs the network. The addition of nodes is critical for maintaining the decentralized nature of a blockchain. This means that if either scalability, decentralization, or throughput are tinkered with, they will affect each other on Layer 1. This is called the classic blockchain trilemma. Hence, Layer 1 cannot be scaled without moving all the processing to a separate layer built atop the first layer. This is made possible by enabling the integration of third-party solutions with Layer 1. A good example of Layer 2 is Polygon, which is a Layer 2 scaling solution used for Ethereum. Other examples include Plasma, state channels, optimistic rollups, and more. Finally, let's move on to Layer 3. Layer 3 is represented by blockchain-based apps such as DeFi platforms and distributed storage apps. Many of these apps have cross-chain functionality, allowing users to access various blockchain platforms through a single app. Layer 3 solutions enhance the capacity of several blockchains by allowing them to interact without the use of a third party or intermediary. Consider Layer 3 protocols as a means to simplify all the layers without adding unnecessary complexity. They act as a bridge between Layer 1 and Layer 2 systems, ignoring the majority of their operational differences. While Ethereum and Solana have a robust Layer 3 app ecosystem, Bitcoin is not designed to support such applications. Smart contracts and dApps that only handle decision-making and execution of follow-up actions form Layer 3. Since the maximum functionality of the blockchain is derived from the innovation of dApps, this is the layer that interfaces between real-world applications and the underlying layers that facilitate everything else. Some examples of Layer 3 are Uniswap, Foundation, and Decentraland. Thanks for listening. That's all for today. Subscribe for more crypto educational news such as these.